Hello dear viewers, welcome to my YouTube channel. Today I want to show you how to do tubular steel connection uh, using Staadpro and Idea Statica. So you can see here my connection. So all my design have passed. So actually this connection was having an error here in Staadpro because you can see the connection is not green because there's an error. There's a warning actually, not an error. There's a warning that states that the joint is not in equilibrium. So you can just confirm. And see, joint is not in equilibrium. This warning here. So you can see Staadpro RAM connection is limited on what you can do when you're designing tubular steel connections. There's not much you can do here. When you change this design code to LRFD, only the warning is still there, so it's not green. So we can solve this using Idea Statica. So I can no, I don't want to say anything. We can solve that using Idea Statica. So actually this connection here, it is this one, this connection, right? So we can solve that using Idea Statica. So if you don't have Idea Statica, it's very simple. You come here, you can just you can click new, insert, and then you can edit. If you want to configure Idea Statica and give it any name, and then you come to command, and then you can go to where your Idea Statica is, and you find this file. You go to C program Idea Statica, and then you find Idea Connection Code Check Manager. So you click Idea Connection Code Check Manager and then open, and then click OK. So from there you can see you have your Idea Statica configured. So we're going to do one connection here. I don't know because for me this connection should be I will not design all of these in this line because I think they should be similar. As long as I design this one connection, you can use similar design for all of these. So maybe I can do, maybe I can pick which connection, maybe I can pick this one. So I'll do this connection here. So this connection is connection number, okay, finding here is difficult, but all my CHB connections or tubular cord connections have a warning. So none of them have passed. So even this one. So I'm going to do this in Idea Statica. So I'll click. So I've already configured. I've already showed you how to configure. So I'll go to now and then to use tools. So you can find this in utilities, of course. I will not show you that. So it's in utilities. So you go to user tools or configure. You can put configure and then you go to user tools and then open. Okay, so I'll open that. So these are the connections that I've already done. Okay. If you can see, these connections are already exist. So I think they are big connections. So just connections. Yes. Yes, I'll save this. So error occurred at 40. Yeah. It's because I already opened several, so I will have to close these ones. I have to close these and that. I will close this. So, so I'll select again. I want to select. Make sure you go to select cursor and then geometry cursor. Then pick your node, the node where the point is. Then select there and then idea. So okay. You can make sure that the code you want to use is American or Europe. You select from there before you open. These connections are I have written down, so I need to not click connection again. Import the new connection that you're importing from. So my connection is this connection number 63. So I select it and then just click finish. Then I open it. Okay, we want to make sure that we are not using I sections. So if you see my solid view, I'm using tubes. So that's why it's tubular chord. So I need to know which type I'm using. So or the size of the tube. So if you go to Staadpro to properties, see I'm using PIPS 120. That is still 36. So PIPS 120. This is the start name. But if you come here, if you want to maybe select, if you want to find, you will not find such a name here because that is a start name. Of course, it's a hollow or a tubular hollow section, circular hollow section. But there is no name such as PIPS here, or even because I'm using AICS, there is no such a name here. So to find that name, you can go just here and then sections. I'm using tubes or pipes. So I hope you can know. Okay, so I'm using pipes. I'm using PIPS 120. So you can go to view table and then you will find PIPS 20. That is the start name. It is called pipe 12 STD. Okay. So when you go to Idea Statica, you will select pipe 12 STD, this one. Then click OK. Then OK. You can see the size of the pipe. So we will select also the same for the others. Okay, and then select the same here. So from this you can see this is a column. So these are not two members. This is one column. So I think I should uncheck member 79, and then member 78 should be now continuous because it's continuous. And now we'll do an operation. So you can either click here or right click, then new operation. So we click add a cut operation. So I will cut member 95 group member 78. I want it to be cutting method to be surface by surface. Okay. So this is how drum connection was designed it. If I can show you, this number is not 63, so we can just go to connections in 63. So node 60 actually does not been designed here. Actually, does not been designed, and even you can see these ones also are not designed. So it was necessary to do that in Idea Statica. So it does not even be assigned any connection. So um, for me, I just not use this well because if there is a warning saying that my members are not in equilibrium, it means even this one will not be in equilibrium. So we need to add another operation. So I will add a stiffening plate. You can see this option here, stiffening plate. Okay. So my stiffening plate, I want it to be facing to come about here. So I can try which angle that is. Either in X, I'm not sure. But it's not that one. So 0, 90. So I will confirm. Yeah, that's the angle. It should be looking like that. Then I will add here some Z because you can see here this one is in Z direction. So in Z direction, I will move it in about, let's say, 8 inches. Actually, it's not in the same direction with this, so I have to just be confined by. So this one should be maybe negative 2, and then X here maybe 8. Let's see. So I want it to come forward. So it's not here, no. So it's here, Y 8. So it's actually negative. Okay, so this one should also be a value about, let's say, 6. Negative 6. Yeah, 6. And then here, let's say, I add it, I increase it to let's say, 3. Maybe 12. Yeah, that was okay. This is how I want it to do. And is it cutting through? I can just review this one between them because I want it to go up to the other side. So you can see the way it looks like. Also, I want to increase the plate size, the thickness to be, because I need to be uniform. So I use just 7/8 thickness. Okay. And then I will add another operation. Now this time I want to cut this plate. So I will add an operation, this cut of plate. This one here. So this is Idea Statica 2021. So you can see already it has done that operation. It has cut plate, this plate group number 78, this column. So I will just copy this operation. Copy. Now I will make it green. Now this number 95. Okay. So this is how that connection will be. So I'll go to setting. I want to check everything, make sure everything is checked. So I check everything here. Go to that chord setup, check everything. Then I can just save or okay. So you can actually see even the cost here. I don't want just to calculate. I want to go and check even backlink. So I'll go to check. I'll go to calculate backlink. Okay, so I'll post the video and wait for this analysis because it can take quite some time. Okay, so you can see the connection has passed. You can see the analysis. You can see the backlink. You can see local deformation. Everything has passed. So you can just go to reports. So it's creating the report. So I don't want this video to be too long, so I'm pausing. But I'm pausing only if the so you can see I can just check all the drawings here. I want drawings in all the X, Y, and Z direction. And then I want to include my bill of quantity. I want to include my cost estimation. I'll pick here. I will not include my formulas. So I just need software information. But I can just include formulas if I wish. And then refresh. So now you can see all the drawings have been included. So actually, this project I'm having. So you can see now I cannot submit this work because of these warnings. Obviously, my client will not be satisfied. So to solve this warning is very simple. It means I need a stiffening plate in all my connections. So I can print this PDF. So I'll print it's corner 63. So I will print and then just edit here corner 63. You can see there is corner 7. Actually, I've done several corners. So I can just go back to design. So you can just generate the drawing for this plate by going just editor, then click to D, then can save to DWX. So just change this corner 3. So I will go when I'm detailing these drawings. I will include all these bits in my connections, and of course using Idea Statica. Using the drawings generated here, I can easily edit, include my just add my plates. Instead of drawing anything, everything I can just using these drawings from here, which I can easily export to DXF, and then using the combine with these plates here, then it will be easier. Just indicate that there are stiffening plates here in my either ArchiCAD or AutoCAD. I advise people to use ArchiCAD and AutoCAD. So just edit this and your detailing will be complete. So I'll go to maybe I need to do for you one more connection. So I think this one was too simple because I showed you this connection is a bit complex. Maybe let me just do this one here. So make sure you right click and then select geometry cursor. Then can pick that corner, and then you go to utilities, go to not configure, user tools, and see user tools in your utilities, then idea static. So let me close this and save it. Let me save, yes. So here you can select the country. I will use US because I'm using AACI code, so I'll open it. Okay, now my corner is not yet imported. I have to click because these are the corners that I've, I've already done. So I have to click connection to import, finish importing. So there's a new connection here. So that is the one we have just imported. So I think this one corner 68, right? This is the new connection. So just click finish and then open. So by just adding some stiffening plates, we can solve this warning which says this corner is not these connections, these tubular chord connections are not in equilibrium. So if we just add a stiffening plate, can solve that. But we need to show how we did it. So we need to use Idea Statica, or you can just have the drawings and the calculation and everything. So Idea Statica is a very useful software. So remember we are using 512 STD, 512 STD, then still 512 STD. So this member is not there, so I will uncheck it here. Then this member will be continuous. Continuous. So remember why I'm using W section. These are W sections. You can check them, right? It's because I'm not using trusses, okay? And you can see this span is too big. This reserve span is too, and I'm designing this steel warehouse, and because I've included earthquake, so and I've not used trusses here, I can just use W section. They will serve better, and my design is going to pass, and my design is not going to fail. So that's why I've used this W section here. So we just add an operation called cut, and then it has already cut. Number 7. So just change it to surface. So let me show you. So if we change this to meter cut, you can see if you change bound box, you can see the way the cut. So we want to use surface like that. Okay. And then I'm cutting by number 45. Let me show you. My number 45. And then I will change this one field with front. So that's the way it looks like. So I will just copy this operation. And then I will change this one out to number 137. So copying is one thing that I prefer most. Whether I'm editing, whether I'm doing anything, I love copying and pasting. And So if you master copying and pasting, then you can do a lot of work. So we need to add a stiffening plate. So another operation, we pick this one, stiffening plate. So you can see, how you can see. Okay, my stiffening plate does not do in the way I want it, so I will just maybe change this angle. Hope it is this one, but yeah, it's that angle. And then I will move it by, let's say 8. Let's see the effect. Yeah, that's the way. So I can just increase it. Just increase this to be maybe to, well, no, 8, maybe 10. Let it just be 8, actually. And then let us see. I want just to make sure that it touches this member, this column. So let me reduce this to 6 so that I can see it both on both sides. Yeah, I can see it both sides. Maybe just increase a bit 7. Okay. Yeah. So that way. And then maybe I can reduce this height here to 1. Let me see the effect. This height, maybe let it just be at 8. Okay. And this one I can reduce it to 2. Let's see the effect. Yeah. Because I'm going to reduce on the upper side. Maybe increase it to 4. Then increase this to 8. Because I want to see it on both sides of the tube of the pipe. Okay. So now I'll add a new operation, that is cut through plate. So a cut of plate. I hope you can see cut of plate. So it has already cut the plate through the column. That is member 45. So I will just, as I have said, copy this operation. Then just change this one to member 135. So how you can see that well. So cut is very important because when you cut, you create that well between that connection. So I will, because of uniformity, I will increase this plate to, as I was using a plate of size of 7/8. So I will increase this plate. Remember, the more the complex connections are, the more expensive, and also the size of the plate may determine the cost because this plate is thick, so it will be costlier. So I will just copy this plate. I will copy. So now I will change this one to, let's say, negative. So I want it to go to the other side, this other side. So you can see it's already moved. Maybe I can increase it further to negative 10. That's not enough. I will increase it to negative 12. Yeah, that's better. You can see actually they are not equal, but we just the first, you can just pick one because I think this member is made for this around that plane. So you can just pick one and then just detail one click. So we'll copy the operation at group paste, copy. Now we are cutting plate 2. Remember 45. You can see the weld has been created. We copy this, cut group plate. Now we are cutting group number 1. We are cutting plate 2. Group number 1, that's it. Well, that has been created. So I think these tubular connections are very easy to solve. So this is how we can easily design tubular steel warehouse connection. So I think this one will pass. So we'll go to make sure we check everything. So code setup, and then make sure you check this because if even detailing fails, it can mean that they are very significant. You have not followed the code or the standard. You can have very significant effect in your design. So you go to check. We want to check backlink. So select calculate stress strain, then backlink. So I'll pause the video. You can see the cost is 51 for this to finish analysis of this connection. So you can see all my connections are fast. So analysis 100%, place 100%, welds. So welds are very important. You have to make sure that also your weld passes because if your weld has failed, basically means that that weld is either not possible or there's the connection has failed and it will fail. So you have to be very careful. You have to make sure that everything passes here. That's why it's important to go and make sure everything is checked. So my backlink also has been done. So we go to report. Report and just check all of this. Make sure my bill, my cost, and then my software information. They already go down now. So it's gonna 68 and refresh. So I've included my view end here, so I'm not then do my view again. So you can see that's the way I want my code to look like. So software information, then I just print PDF and save it now as corner 68. Corner 68. Let's save. Then I can just go back to design. Okay, my report has opened. Then I can just generate section here. Then I can just create section. Create section. Not coming the way I want it. Section. So then just go back to reports, then view end. Then you go to view end. You can see all the sections that we created are here. So just open all these sections or just print this VOM. Very important because you can see now we know exactly the dimensions of our plate, but for me I think V1 because the size of my place really doesn't matter because my plate size have been varying. They have all been varying, so you can just be random select and use for all the sections. So as long as you have this calculation to prove your design. So this is what I use to prove my design. And just also print the VOM, the VOM. So that will be it for today. Thanks, guys. Please subscribe to my channel. If possible, we could do another connection, but I think we have done enough. So, uh, thanks.